So hello, my name is Adrian. This presentation is entitled Mirai to Monero, 1 year's worth of Honeypot data. And I'll walk you through some of the things we see running our own Honeypot network, and I will try to explain to you some of the exploits, techniques, and attacks that we see, and some of the insights we gain into what attackers are and do. There he goes. So, who are we? That's me and my colleague Mirai. We're the two authors of this presentation. We're both senior security researchers with Ixia's application and threat intelligence team. We love exploits, malware, honeypots, tinkering, and stuff like that. But we're good guys, so we only do the part where it comes to detection, simulation, and emulation, and stuff like that. And we hope to finally become unemployed because at some point security is solved. We'll manage somehow. And if you like us, please feel free to follow us on Twitter, of course, shameless plug. Now, you might be wondering about the royal we in this presentation. The reason for that is that that's Mirai right now. He's somewhere nice and warm, and that means I'm the only one who's going to be entertaining you for 30 minutes. And on to the good stuff. There it goes. So this is a view of our honeypot network. Like I said, we have a geographically distributed network. That's not the one-to-one mapping. That's just the fact that I have very poor skills with clustering and graphing. And I would like you to first think about these questions. What do you think attackers are like? If you have an image in your head, please think about it. And I'll walk you through some of the stuff that we generally see, some assumptions being made. Some people imagine them as simple script kiddies. So, you know, this guy, he just thinks he's a hackster because he grabs a script off the internet, runs it against a website, and that's it. I'm an almighty hacker. The media, you know, talk to us about these bad guys, you know, criminals toiling behind a laptop somewhere and then just going somewhere to enjoy a vacation from their hard-stolen money. And if you work in a position of power, you probably have an idea that's more like this. And just an interesting side note here, if you think machine learning is at the point where it's finally solved security, the machine learning generated alt text for that image is screenshot of a cell phone. So I don't see a cell phone in there, and we should wait before figuring that out. So this is what I'd like you to tell you I think attackers are. I think they're persistent. I think they're not very fashionable. I think they're resourceful. I think they're opportunistic. I think they're a combination of all of the above. And I think they're driven by something, right? They want to accomplish something, otherwise they wouldn't be hacking systems. And I also think they have a preference for targets in the US. So I don't think it's some grudge or geopolitical stuff. Probably has to do with the fact that a lot of great services are hosted in the US. And please do not take this as an idea to secure your network by moving out of the US. That's not going to solve anything. So I said attackers are persistent. And when you think about persistence, what can you think of in security better than brute force? What's more persistent than trying millions upon millions of username and password combinations, right? We monitor a lot of different protocols and services. Some examples, Telnet, SSH, of course, web-based protocols and applications, and the long list of that. And we see a good number of attacks coming from these. So this is a graph showing you stats from January to September of this year. And the counts themselves might not appear that high, and the reason for that is we tend to bucket the events we see. So just one username password combination is not an event. We bucket them by the hour. If 1 million come in 1 hour, that's one event. So to get a better idea, there are 700 hours of time in 1 month. So every 700 hours of time, you get 200,000 hours worth of brute force attacks. That's the scale of brute force that you should imagine it. We also see quite a large number of IP addresses, different IP addresses being used, some of them recycled from time to time, some of them just continuously appear there as being used, proxies and other stuff, of course. And there's a decrease that seems to appear for some reason in spring. I don't know, there might be vacations or something. Most of the brute force attacks we see tend to target Telnet and SSH, and that's most likely because they're connected to a botnet, which I shall not yet name. You probably have an idea which one it is. We also see a lot of attacks against database servers, so we monitor attacks against MySQL and MS SQL. And one other candidate I like to point out as being important is VNC. The reason for that is right here it's at position number 9 in our top 10, but this is a per year statistic, and we've been monitoring it for 1 month. So 1 month the VNC brute force suddenly takes it in the top 10. So these are the stats for October, and in October suddenly it rises to position number 4. So if you feel safe because you don't have Telnet, SSH, and database servers, you might consider if you have a VNC server somewhere listening on the internet. One other example of persistence I'd like to talk about is connected to something called Cisco Smart Install. So this is a feature, a boot to config feature for Cisco devices. And at some point this year, a vulnerability came out saying that you can achieve code execution by downloading, uploading configuration files via unauthenticated TFTP. Already sounds like a bad idea. We don't see an enormous amount of hits like we do for other things, but still impressive considering that we're running simple VMs, Linux VMs, and not Cisco devices. They're just Linux machines with Python scripts on them. So another bad idea to secure a network, Nmap doesn't say there's something over there. Well, if they find an open port, and if they can communicate with it in the way that a vulnerable device would, someone will definitely try to attack it and exploit it. Now, you might be wondering, why is fashion brought into discussion at any point? What do I mean attackers are not very fashionable? Well, in security, we tend to talk a lot about what the newest and latest tool or exploit is, what the newest technique is. And attackers don't necessarily care about that. An attacker doesn't care. He cares what works. He cares what's easy to use and what's readily available and what can target a large number of devices. Case in hand, this is a 5-year-old CVE targeting Dahua DVR devices, and we've been monitoring it since August. Already seen hits on it. There's a constant number of hits on it from different IP addresses. And an interesting point here is that we've implemented communication messages for its protocol from all public POCs we could find. As a result, 97% of the messages are unknown. So either there is something shady going on out there, or there are too many CVEs that don't have any sort of public description whatsoever. Work in progress, this is something that seemed interesting to present. Also from I would probably expect this whole thing to have died out, Eternal Blue. If you have any idea about it, you probably recognize it as the exploit behind the WannaCry malware infection from last year. So WannaCry leveraged Eternal Blue, and given the size of the WannaCry attack, I would have definitely expected this to die out. Okay, I would have expected the graph to go in the other direction and not this one. Truth of the fact is, in October of last year, we saw 100,000 attempts at Eternal Blue-based exploitation, and in September of this year, we passed 3 million. 30 times more than last year. And the only reason why someone would continue doing that is because they can actually profit. So this means there are a lot of devices out there still vulnerable to the same exploitation method that was used by WannaCry. That's kind of sad news, to tell you the truth. Also, in the oldies but goldies front, NTP and DNS, which a lot of people probably don't consider to be attacks anymore, because like, whoa, they're old. Those protocols that used to get abused a long time ago, they still do. We have 2 months worth of monitoring and 321 million attempts to exploit this. So these are used for reflected distributed denial of service attacks. Okay, so you'd expect a large number of attempts because you have to do a lot of requests to be able to do the DDoS attack. Still, if you think that you want to expose a DNS server out on the internet and make an open relay, you will probably want to allocate a lot of CPU and bandwidth because people are just going to require all that power. Now, attackers are resourceful. Like I said, they will use anything at their disposal. Any tool, any public POC that appears can be and will probably be leveraged by someone. Case in hand, last year in November, I was looking at our Honeypot data, found some interesting requests, exploit attempts, mentioning something called X-Attacker. Okay, so I Googled it, found a project uploaded on GitHub just 1 month prior to that, and thought, hey, this might not be something, it's one tool, has a lot of old exploits inside it, just something in a corner of the internet. Well, it just went on from that point, so right now, it's a nice project, it's got a good number of forks, nice word cloud, they added the word cloud so you know what it does, you know, pen testing targets and whatnot. It's got technical support, so there should be an issue tracker over there. 37 closed issues containing requests for new exploits, support for people not being able to run the tool and all of that. Updated README file, updated changelog, stuff that some software projects don't have it actually. And recent commits. And this is just one tool from GitHub. GitHub is that place where you have millions of projects. You probably don't expect people to actually access some of the stuff there from time to time. The truth is, it does happen. We do see this tool exactly being used because it's got a trademark string inside it. Not millions of attempts, but a couple of hundred attempts. And the truth is, the number of attempts itself doesn't matter because what an attacker needs is one successful attempt. Just one is good enough if he gets the right one. I also claim that attackers are opportunistic. Given a window of opportunity, they will probably try to take it. This example comes with Drupal 2 and 3, two remote code execution vulnerabilities in the Drupal framework that came out this year. A couple of weeks after the public POC appeared for the first one, spike in attacks. Then it tends to die out. Then the public POC comes for the second one, another spike in the number of attacks. Now, Drupal itself is a framework that is pretty secure, and administrators probably patched it, so this died out, most likely because there were no more targets of opportunity. This just comes to show you that if you have a small window between the time when the public POC is available and the time when patches are finally made, attackers will try to exploit it. And like I said, you can find things that are combinations of all of them. So we've been tracking multiple vulnerabilities for D-Link devices. That long tail that you can see on your left side is a bunch of older vulnerabilities that still get hits every day and from time to time. And then at some point, you see the spike. The spike itself is a remote code execution vulnerability, a new one that appeared this year for some D-Link devices. When that happens, the next thing we can see, a whole lot of interesting traffic, all of it for that new POC. And this one, because D-Link devices don't get updated as often as Drupal websites do, this one just continues on and on and on and on. And again, I will not name the customer for this one. And one more example of attacks in the wild and techniques. So like I said, we monitor MySQL. We have a fake server of sorts. It gets attempted brute force a lot. Sometimes we tell them, OK, you're successful, you're in. What are you going to do now? So the first thing you generally want to do is gain privileges. Grab as many privileges as possible. And someone took that very literally. I think they just copy-pasted all possible permissions in there. I actually learned about a couple of them that I didn't even know existed. Replication, slave, and client definitely seems, yes, you need that. And then you want to be able to execute code on the server. So to execute code, you don't necessarily have the easiest tools available. But there is a technique, and it's connected to that select long hex string statement that you see. That one continues with into dump file. So MySQL, being a database server, allows you to select data and save it to an output file. In this case, the output file is PowerShell, not the exact type of data you would expect to see. Decoding that hex string, it's PowerShell code that should get executed. It would access a website, download something, and then execute it. But how do you go about executing the PowerShell code itself? You still have to call PowerShell. So MySQL has a feature called creating user-defined functions. What it allows you to do is compile a DLL file or an SO file under Linux, where you define a function that you will then call from MySQL itself. So all you have to do is compile system of string inside a DLL, send it to the server using that magic select statement after you've gained access, and then you can just create a function alias and then call it, just like those select syseval cd/temp wget statements up above there. So this is not a new technique. This has been around for a good number of years now. You can find blog posts, you can find references to it, you can find a lot of info on how to use it. But I thought it would be nice to show you just one of the tools and techniques out there. There it goes. Okay, so I said attackers are driven. Now, I won't talk to you about psychological drive and stuff like that because I'm not a psychologist. I'm an engineer, so I can talk to you about the tools they use, the malware they use, and what they can use it for. And first purpose, of course, DDoS attacks. And now you know the major botnet I was talking about because you probably missed it in the title. So that is Mirai. Mirai is this large botnet for Linux-based IoT devices that appeared last year. It managed to generate what some people say are 600 gigabyte per second and over 1 terabit per second attacks. So very large-scale attacks, very hard to stop something like that. And then the authors said, hey, we don't want to do this anymore, we're just going to give up. Which they did after open sourcing the code, because that is always a good idea. Open source something that powerful for everyone to use. And use it, people did. We saw clones coming out, a lot of different clones of Mirai, or just simply reusing the same code. We saw an increase in the number of events, and I'm not sure you can see those counts over there, so I'll just zoom in a bit. 128,000 events in October of last year, and we've passed 20 million last month. So Mirai was one botnet capable of generating 600 gigabytes per second. Now people are advertising Mirai-based botnets that they claim are capable of 400, 500, and we actually have a lot of these right now. We have a lot of different botnets, which maybe individually they have less firepower than Mirai had, but if we put them all together, I don't even want to imagine the ravage that they should be able to do. Now you might be wondering, how hard is it to grow a Mirai network? Well, last month, Fortinet published a blog post about a DDoS for hire service that at some point said, hey, let's use Mirai to power our botnet. They talked about it growing from sometime in mid-September. So we looked at our Honeypot data, tried to identify the botnet, found it, and this is the number of infection attempts we get from it. In 2 days, they went from 0 to 30,000 different attempts per day. That's how easy it is to grow a Mirai-based botnet. There are so many vulnerable devices, it's actually very easy to grow it. And if you're thinking IoT is insecure by definition, because that's the state of things, desktops are safe, well, we have a nice Windows-based bot. We see it mostly via MySQL and Eternal Blue. It's called Nito. It's been around for quite a while now, pretty old. Just stays on your machine, does some fingerprinting, sends some data, then waits for a target, and then starts bombarding it with the DOS requests. And if you're thinking, wait, but Windows is insecure, we know Windows has its issues right now, right? We have a lot of different Linux-based families going out there, multiple documented families. I'll just walk you through 2 of them. One is called DDoS TF. First time I've seen it was in 2016, I guess. The other one, DoFlu DDoS Trojan. And you might be wondering, wait, but you're saying this is old malware. How can you be sure of this? Well, we do some validation. For example, DDoS TF has a giveaway string inside it. The other one, you can simply decrypt a couple of CNC websites. So it's easy to see old malware being reused by people all over the place. And you can have a presentation called Mirai to Monero without some reference to Monero, right? So coin mining is something that once we get image back, okay? Coin mining is something that, is a lot harder to track attackers for, so I think it's a lot harder to prosecute. A lot of people have switched to that. We see a lot of it going around. Monero is the go-to currency. They reuse open mining tools, so they will download XMRig or something and start mining on your box. One example from the Eternal Blue Honeypot. So it receives a command script that is going to execute. The first thing you can do when you get on a machine is to kill off the competition. Why are you mining on my machine? This is my machine now. Kill the competition, fingerprint, determine what capabilities the box has, and then you will download the necessary binary and execute it with nice enough configuration, so you send everything to the right wallet, of course. And I want to ask you if you notice anything strange in there. So this is the download string. This is the part that does the actual download, and I'll zoom it up so you can see it. So certutil is a legitimate Windows binary. It's normally used for certificate management. If you give it the right parameters, you can actually turn it into wget or curl for Windows. So pen testers no longer need to send VBS scripts, PowerShell scripts, and whatnot to download your malware files. From now on, you can just use certutil for this purpose. This is not a new technique per se. It's recent, but it's been described before. One example from one of Xavier Merton's IAC diaries. Just another nice tool and technique that you can see used in the wild. And we've talked malware. No discussion of malware would be complete without some sort of espionage and backdoor tool. So this is an older Trojan, again, known as ZGhost. Main source we've seen it coming through is the Eternal Blue Honeypot. It's an allegedly Chinese backdoor as origin. Some people say it might or might not be connected to the older Ghost Rat. If you're familiar with Eternal Blue, the payload that comes after the exploit comes via a DLL file. These DLL files just contain a URL in this case. The URL will get fetched, and the binary download from there gets executed, and that's the Trojan itself. Again, validation via payload configuration description. You can find a lot of references to it online. And while looking into one of these samples, I noticed something strange. It had a URL inside, so I fetched it, and it downloaded 8.5 megabytes of data. Now, malware tries to keep invisible, keep sizes low. 8.5 megabytes is huge. That seems interesting. I looked into it. Static analysis said, okay, this is a malware binary packed with Amida. Okay, good packing there. So I sandboxed it. And what do you think I found? What do you think the most prevalent malware in 2018 would be? No ideas? No. Mining, that's it. Someone finally said it. So once you get on the man's machine, you can spy on him, you can do whatever you want, might as well make a buck out of it. Okay, so that's about it from the data part. I guess I should probably be telling you this as a forecast. The internet is still and will be a dangerous place for the foreseeable future. But I thought, hey, this is kind of, depressing, it's pessimistic, and most of my days in INFOSEC, reading the news, I feel kind of like this. So I wanted to say something more uplifting. And thinking about the things I said about attackers, that they're resourceful, that they're persistent, I said, okay, most of that stuff probably applies to the people in INFOSEC as well. So I'll leave you with a better ending quote. I think we should stop demeaning attackers and just imagine the fact that they are a lot of like us. And I'm sure that if they can break a lot of the things we build, then we should probably be able to protect them as well. So thank you. And if you have any questions for me.
Thank you very much. Now we will be taking questions and then going to our favorite time of the day, lunch. So raise the hands. We have goodies for you. Have a question here.
Hello. Yeah,
Please
mic
keep
is
the
off.
microphone closer to your, and
I'm not sure if I understood right the remote code execution technique used for MySQL. So the attacker is using the input-down file, selecting the time file command first to drop the DLL.
Yes.
And the DLL has a few exported functions and those functions as support functions.
Exactly. So you've brute force it, then you send the DLL file that allows you to actually call system code, which MySQL doesn't have by default. So you just do a call to system or eval or whatnot, compile it into the DLL, send it over there, and then you can call the function from the DLL so that it's going to call that for you. Thank you.
thank you. We have a question in the first row, and then going back here. Please make sure to speak directly into the microphone so that we can all hear you.
Identify the malware solely based on the traffic, or did you have specific VMs with specific vulnerabilities?
To catch the malware coming in, we have specific honeypots, multiple types of honeypots. Then we do some analysis of the malware ourselves. Sometimes we sandbox them, execute them in VMs, and see what they do. Most of the time, we try to do all of them if possible.
Would you be able to identify the malware based solely on the packets you received?
If we would be able to identify, so basically you're asking if a piece of malware just uses an exploit, or?
Whether the packets you capture.
Can you speak, please, closer to the mic, or it's not working? Or no, it's not working.
Okay, so the question is, if I understand correctly, if I'm able to identify the malware just by the packets that get sent and received?
Yeah.
Well, we do some of that. We do try to create our own signatures for some of that work to identify them. It's not always entirely possible because a lot of the malware nowadays uses different types of encryption for the payload or some sort of custom binary protocols. You look at it and it's a blob of gibberish. Sometimes you might identify some parts, for example, with, I can't remember exactly what it was. It was one of the Windows-based bots. It would send in the beginning an isolated little header, and then a hex digest, and then an encryption key. But the encryption key was encrypted asymmetrically. So I have no chance of breaking that. I actually have a chance of breaking that if he uses plain old Windows encryption services, because we can do memory dumps. Otherwise, you have to do, live debugging and trying to identify stuff like that, but that means that you don't have any chance of automation in the future. You would have to have too much inspection into the system to be able to do that.
Okay, sorry, before, I'd like to take a question from this here somewhere. Yes. And then we'll go back to the front row.
My main question is, how do you count these attacks? Do you have
How do I identify? I'm sorry, I can't hear you very well.
can you hear me now?
Yes?
Okay. How do you count these attacks? You show some
How do we count the attacks? Well, it depends on the type of attack. For brute force, like I said, we try to compact them because otherwise there are too many. Otherwise, if it's just one request that he would have to do, in the case of the D-Link RCE thing, you just send a request to a CGI script with a parameter. We just count those. Each request is a different attack. They're against us, so we host our own seemingly vulnerable services, which then receive these attacks.
Thank you. We have a question here in the front row. We have moved a bit.
I have actually two questions. One of them is, so let's say you have a simple VM which you leave the SSH port open. What kind of, let's say, automated scans and brute force you can expect from it? let's say we have just a simple VM on AWS, and then you forget one port open. Like for an average, let's say, user, what kind of automatic scans and brute force attacks you will expect?
You'll see loads of brute force attacks. They generally reuse password lists from what I've seen, so they don't just go about completely brute forcing and doing password generation. They use password lists. Some of them go as little as 100 passwords. Some of them use maybe like 1,000 passwords. We actually had to count the number of passwords because one of the protocols used encryption, and we couldn't decrypt it, so we just created some sort of intermediary digest thing. So we had to generate our own password lists and see how they overlap. So, for example, Mirai only uses like a couple of hundred passwords, I think it was, where this other one used 2,000.
And the last question is regarding the Honeypot sandboxes that you're having. Are you regularly changing them? Is there like maybe a chance that this malware will detect that you're a sandbox?
Well, sandbox detection, yes, it does happen. So we have taken some steps to cloak them from malware detection. A lot of stuff involving CPU customization, creating fake files, the general stuff. As for the honeypots, the best thing you generally can do is just move them around, because at one point you can see the number of attacks against them decrease. That's more difficult to do. We do it. But it's not something that you can easily do with a lot of providers, because they don't have support for automation. You have to go and manually click launch instance, launch instance, launch instance.
We will be taking one last question there. And then we will be heading to lunch. Meet me halfway.
Well, my question, do the attackers use Bitcoin, and if so, did you try to track down the transactions?
No, I've never seen them use Bitcoin in my experience. I don't know if anyone else did. All I've seen is Monero. The reason for that is somewhat connected. A lot of the devices they hack into are Intel or AMD devices, and Monero's hashing algorithm is optimized for these. So there's some point in using that. There's also Zcash that I've seen at some point, but most of the stuff I've seen recently is strictly Monero.
Well, I still...
About the wallet tracking, you also asked. You asked about wallet tracking, if we do any sort of tracking.
Yeah, tracking.
Yes, we did look into some of these wallets. Now, with Monero, it depends on the pools that you connect to. Some of them, for example, allow you to see someone else's balance. We've seen some guy make somewhere around $8,000 or $10,000 in 1 month. Pretty good payday. Others don't allow you to track. And we've also seen some sort of proxy service where they do not have to specify inside the protocol, inside the communication protocol, the wallet, because the wallet is then hosted on a VM somewhere, on a server somewhere. They just connect to that, send the data, and that one adds the wallet. And those guys we can track in any way.
Okay, thank you.
Thank you very much once again. Thank you. Let's have a final round of applause.
Thank you.